This is Mr. McVeigh. What I have for you today is exponential growth and decay. This is going to be applications of our exponential function or real-world problems. If you recall from a previous video, we talked about basic exponential functions and our formulas, and they looked like this: y equals ab raised to the x power. And we knew that a was the initial value, or in this case, the y-intercept. A is equal to the y-intercept. Here's the y-axis. And if b was greater than 1, we knew the function was increasing. If b was less than 1, greater than 0, we knew it was decreasing. And that's important for our applications coming up in these examples. Exponential growth. Remember, we talked about growth is the same thing as an increasing function. So growth, we know, has to climb, get more positive as or increase as x increases. So as x increases, the function increases. Here is the formula or the equation for exponential growth. It relates to our basic one, our basic formula by y equals a times b to the x. You notice what I have in parentheses here, that's equal to the b. And for that to be growth, this has to be positive. This particular number in the parentheses has to be positive for it to be growth. Well, the only way that can happen is if we add something to it. So it's 1 plus r. Let's define what each one of these are first. Not r, but A-R-E, R. A is the initial amount. A is the initial amount, starts right here. It's the same thing as the y-intercept, or the y-intercept, as you know. Intercept. R is the growth rate. R is the growth rate, and that's in a percentage. That's going to be in a percentage. You'll see in just a minute on our examples. T, usually for exponential growth, T, our x is t for time, because in the real world we think of time as time moves on, something decreases, maybe we gain more money, we lose money, or we gain more popularity, or we lose popularity, or we gain more items, we gain more things, or lose things. So we usually use exponential functions in application functions as t for time. Okay, so our function is y equals a 1 plus r to the t to the time. We notice that the percent has to, the growth rate, or percent, it has to be positive, and we have to add to it to have an exponential growth. Okay, so let's work some examples, and you'll see really quick how this works. I'll come back to decay in just a minute. Okay, exponential growth. So we know the function, again, is y equals a 1 plus r to the t time. Okay, so let's read this question. The original value of an investment is $1,400. Well, remember, A is the initial amount. So the original value, initial amount, it's the same thing. So we know our A, in this case, is equal to $1,400. And the value increases by 9%. So R, my rate, R equals 9%. And here's the key. Remember, this is in percentage. You have to put it in decimal form, so I have to divide by 100. So that ends up being 0.09. And T, use the exponential function to find the value of the investment after 25 years. Well, 25 years is my time, so T equals 25 years. And so I substitute these values into my equation. So I need to find the value of my investment after 25 years. So this is going to be my value, y is. And so y, my value, equals a of $1,400 times 1 plus, my r is 9%, so it's 0.09 to the 25 years. Okay. Now you're going to need your calculator for this to actually calculate this. You can use your phone, or if you have a calculator, use it. So I'm going to turn my calculator on here and I'm going to clear it. I'm going to type it in just like I see it. $1,400 times my parenthesis 1 plus 0.09, close my parenthesis. I'm going to use the caret symbol, the hat, for my power to the 25. Okay. I press my enter key and my answer is going to be 12072.31. Remember, this is a value of my investment. So this is dollars. This is money. This is money. So my answer is $12,072 and what is that? 31 cents. And I box it. And that's my answer. Let's try another example. Okay. Here's my equation again. Write the equation down every time until you get really used to doing this. Okay. So my A, I need to know what my A is, my initial amount. I need to know what my rate is, and I need to know what my time is. So I'll read this question. The number of student athletes at a local high school is 300 and is increasing at a rate of 8%. So I'm starting with 300 athletes at the school. That's my initial amount. And it's increasing at a rate of 8%. So 8% in decimal is going to be 0.08. So this is what I use. And it wants to know, use an exponential function to find the number of student athletes after 5 years. So my time is 5 years. Okay. Now I substitute each one of these values into my equation. So the number of student athletes, Y, is equal to my initial amount of 300 times 1 plus 0.08 times my time of 5 years. I get my calculator out. I type it in just like I see it. 300 times parenthesis 1 plus 0.08. I use the caret, the hat, the rooftop symbol for my power in 5 years. Press enter, and I get 440 point, and I'm going to round this to 0.8. Okay, so this is student athletes, isn't it? But we can't really have a 0.8 of an athlete. So in the end, we're going to say, since it's greater than 0.5, we're going to say 441 athletes. We rounded it up, and that is our nice little answer. Okay, so that's how you do a growth equation. That's growth. Now, decay is very, very similar. If you remember, and I know you will, recall that our original equation is y equals a b to the x. Well, if b is less than 1, then it's decay. So if b is less than 1, then our function is decaying like this. For the only way that to be less than 1 is we have to subtract something from 1. And again, our formula is A is the initial amount, R is the decay rate. Before it was the growth rate, now it's the decay rate because we're subtracting it. And T is the time. Okay, T is the time. Let's look at an example or two. Okay, I'm going to write my formula down, and you should too. Every time you work this, write your formula down. Y equals A times, in this case, it's 1 minus R to the T power because it's decay. So it's decreasing. So we need to know an A, we need to know an R, and we need to know T for time. Okay, so let's read the question. The population of the town is decreasing at a rate of 1% per year. So the population of the town is decreasing at 1%. So our rate is 1%. Or we have to put that in decimal. It's going to be 0.01. In the year 2000, there were 1,300 people. 1,300 people. That's the initial amount. Use the exponential function to find the population in 2008. So how many years went by between 2000 and 2008? Can you guess? Or should you subtract? Well, you can subtract. The easiest way is, if they're big, is just subtract. Minus 2000 equals 8. Now this, you can see 2000, 2008 is 8 years, but these numbers could read really far apart, and you would need to subtract would be the easy way to do that. So we got 8 years. Now all we need to do is substitute our values, our three values, back into our equation. Okay, so we're trying to find the population. So y in this case is the population equals my initial amount times 1 minus 0.01 to the t of 8 years, time of 8 years. Again, take my calculator, enter in my values, just like I see them. Okay, so I have, let me clear this over here. There we go. I have 1,300 initial value. Type that in right. 1,300 times, just like I see it, 1. This time it's minus 0.01 because it's decay, raised to the 8th power, and I get 1199.6. 1199.6, and that's a population, that's people. So we're not going to have a 0.6 person, so it's going to have to be either a whole number, so we're going to have to either round it up or down, and since it's greater than a half, then we'll round it up to 1.99. That's going to be 1,200 people. Okay, another example. Again, write your equation down. Y equals a 1 minus r, that tells me it's decay, to the t. An investment of $8,200. So I'm starting with $8,200 is my investment, or what I put in the bank, or however I invested it. It's $8,200. So I know my A is equal to 8,200. I'm losing, lose. Look at that word, lose. That means subtract. That means decay. It's going away, taken away. R, my rate is 2%. 2% equals 0.02. And my time, it says 9 years. So T equals 9 years. It says use an exponential function, which is what we're doing, to find the value of the investment after 9 years. So I take my values, I substitute them in. Y equals 8,200, 1 minus 0.02 to the 9 years. This is money. So I type it in just like I see it. 8,200 times 1 minus 0.02 raised to the 9 years. $6,836.73. And we are finished with that particular example. And that is the value of my investment after 9 years. You notice I lost money. I went from $8,200 to $6,836.73. Now, if I wanted to know exactly how much I lost, I would just subtract this amount from the 8,200. At any rate, that is all I have for you today. If you like this video, please like it, and I'll create more like it. Mr. McVeigh, goodbye.